Good day. Today we're going to discuss HE 2251 Module 5 concerning the topic friction. As we have learned, friction is a force that would resist the relative motion of two forces in contact. It will always act tangent or parallel to the surface at points of contact. It is always directed opposite the direction of possible or existing motion. There are different types of friction, which will include the internal friction, fluid friction, and dry friction. For internal friction, this is defined as an internal force that would resist the movement between particles of materials while undergoing deformation. Example of internal friction would include the friction on soils and in granular objects. Fluid friction is the friction between layers of viscous fluids moving relative to each other. When we say fluids, this would include your liquids and gases. So, fluid friction resists the motion of either within the fluid itself or of another medium moving through the fluid. So, air resistance is a form of fluid friction. For dry friction, this occurs when unlubricated surfaces of two solids in contact are under sliding condition or tendency to slide. It is sometimes called the Coulomb friction, as Agustin de Coulomb is one of those who studied it extensively. A form of dry friction is what we call static friction, which is a friction or force that resists the impending motion or starting motion or slippage of an object. It will vary from 0 to the maximum value that may cause motion. Once our maximum value has reached, it will now start to experience what we call kinetic friction, or sometimes called dynamic or sliding friction. This occurs after the slippage or motion has happened already. Here is an illustrative example of the types of friction. We have rolling friction, static friction, your fluid friction, and your kinetic friction. So we have what we call the coefficient of friction, which is the relationship or the ratio between the force resisting motion and the force pressing the surfaces in contact, or that is represented by the Greek letter mu and is equivalent to frictional force divided by the normal force. In the case of static coefficient of friction, this is now our mu s equal to Fs over Nf. And for kinetic friction, this will be given by mu k equivalent to the kinetic friction divided by the normal force. So next we have the angle of friction. So let's take from the given diagram. The angle of friction now is defined as the angle made by the resultant of the normal force and frictional force measured from the normal force. So from our description of coefficient of friction, it is equal to the ratio of friction to the normal. So comparing it now to the diagram or the triangle made by the friction and normal force, we could now say that the coefficient of friction is equal to the tangent of phi, or the tangent of your angle of friction. When your friction force reaches its limiting static value F max, the angle of phi also reaches its maximum value phi s. Thus, tangent of phi static is equal to the coefficient of friction static. And when your slippage or motion occurs, the angle of phi will have a value of phi kinetic corresponding to the kinetic friction force. Thus, we'll have tangent of phi kinetic equal to the coefficient of friction kinetic. So there are four situations where a rigid body in contact with the horizontal force or surface can occur. So if we have here your force says weight, we have your normal force since there's contact between surface. We have a vertical force applied on the object. This situation now will have no motion, therefore no frictional force. If we have here an inclined force to the block of wood or a horizontal force, then we will have a force applied which is less than, or frictional force which is less than mu sub s times the normal force, and this will also be no motion. If now our friction force is equal to mu s times n, then this is a situation where there is an impending force or starting motion. And lastly, if we have now the kinetic friction is lesser now than your p sub x, we will have a motion, or we have already started the motion. So to understand example friction, let's have an example. A block of unknown mass is initially at rest on a 30-degree inclined plane. Determine the value of mass if a 30 kN force parallel to the surface is sufficient to start the motion up the incline. Coefficients of friction between the two surfaces are 0.27 and 0.18 for static and kinetic respectively. So before we start our solution, we draw first an FBD. So we have your applied force along X, we have your weight vertical, so it will have an X component and a Y component. So there is a frictional force which is directed downwards the incline as our motion is upwards, and you will have your normal force. So from this FBD, we'll be able to solve for your summation of forces X equal to 0. So we have now applied force minus the frictional force minus the X component of the weight. For the WX, it's equivalent now to W sine of theta. For summation of forces along Y, it will now be equivalent to 0, and it will be upwards positive. So NF, or normal force, minus YW, or Y component of weight, is equal to 0. So weight now, Y component is equal to the weight cosine of theta. So we do not know the mass, so we have now one unknown and you do not also know your F. So we have two unknowns and two equations, or three unknowns. We also do not know your NF. So we have three unknowns, two equations. So we could take the third equation from F equal to mu times NF, or that is now applying the applied force 3 kN force minus mu static, since we are just to start the motion, so static 0.27 times the normal force minus WX. Substituting now WX and our force, so we'll have now 0.27 NF is equal to, is taken from this equation, then we'll have W cosine of theta for NF minus W sine theta for WX. So you already have one unknown only and one equation. So W now is equal to 4.088 kilonewtons, and the weight now, or the mass, will be equivalent to weight divided by 9.81, or that is 416.73 kilograms. So next, example 2, two masses are connected by a pulley system as shown. Determine or masses are 2 kilograms and 4 kilograms. Coefficients of static and kinetic friction are 0.28 and 0.23 respectively. Determine the force required to pull the 2 kilogram mass up from rest. Determine the force required to keep the mass in motion. So for our FBD, we have to divide it into two. For your 4 kilogram mass, we have your horizontal force that will cause motion. We have your frictional force between the 4 kilogram mass and the table. We have the weight and the normal force, and also the tension between 4 and 2 kilograms. Then for your 2 kilogram mass, we'll have the weight of the object and the tension of the object. So from these FBDs, we can now solve for our values. So for the force to start motion, we use the value of static friction. And for the force to keep the system in motion, this will now be using kinetic friction. So for the 2 kilogram mass, this will be our FBD. So our equation now will be summation of forces vertical equal to 0, positive upwards. So T minus W equal to 0, or T is equal now to the weight, which is 16.92 newtons. So we apply this to the 4 kilogram mass. So we'll have now summation of forces along the horizontal is equal to 0, positive to the right. So we will have now force applied, negative, plus tension plus frictional force. So that is equal to, or the applied force now is equal to 16.92 plus friction force. But we do not know our frictional force. So we'll take this from mu equal to F over NF. But we need to solve first for the normal force by summation of forces vertical equal to 0. So upwards positive, so we'll have NF minus the weight is equal to 0 plus or 0. So NF now, or normal force, is equal to the weight, which is 39.24. So from coefficient of friction, we'll have now Fs, since we are solving for the force to start, is equal to 10.99. So F now to start the motion is 27.91, and for our force to keep the motion, will be solving for the kinetic friction using your kinetic coefficient. So Fk is 9.03 newtons. So the force to keep the motion, or the uniform motion of the system, is 25.95 newtons. So next we have the uniform 100-pound plank is resting on friction surface A and B. The coefficients of static friction are shown in the figure. If a 200-pound man starts walking from A toward B, determine the distance x when the plank will start to slide down. So for this problem, we have to, again, draw our FBD. So we'll have the weight of the man, weight of the plank. We have for point A, it's frictional force and normal force. And for point B, we have your friction and normal force, but it will be directed to the surface of contact. So for our solution, we start off with summation of forces along A, or about A. equal to 0, clockwise positive, since we are solving for x measured from A. So we'll have 200 times x plus 100 times 5 minus NB, or the vertical component of NB, which is cosine of 40, so times 10, minus the vertical component of FB, which is sine 40, so times 10. This will be our equation 1. So to solve for the other unknowns, we use summation of forces horizontal equal to 0. So we'll have FA plus horizontal FB, which is FB cosine 40, minus horizontal of NF at B, which is sine 40. So we have more unknowns, so we'll have equation 2. Next, summation of forces vertical upwards positive. So we'll have NF at A plus vertical of the friction force at B minus the normal force at point B minus 200 minus 100 equal to 0. So we have 1, 2, 3, 4 unknowns, but we know your coefficients of friction, so we apply now 0.2 times NFA plus 0.5 for B, and then this becomes 2A. So for equation 3, substitute coefficients of frictions. So we'll have now equation 3.A. So solve simultaneously 2.A and 3.A. We will now arrive at the values of NFB and NFA. So you can substitute it at equation 1, giving us a value of x equal to 4.34 feet. So that's it for Module 5, Friction. Evaluate, please answer problems 3 and 4 only.